Okay, today we're going to show you how to write chemical equations from formulas and words. Okay, so let's look at this chemical equation right here. Here's my model equation, right, and that's balanced and all that. So there are three ways we can write a chemical equation. We can use just words. We can call this thing called the skeleton one, which gives us the basic information of the chemical formulas, but no, it's not balanced, and it may or may not have the correct states of matter here, right? And then the complete and balanced one, which is the one we're going to use in class for most of the time, is going to be the one that has the correct formula, the correct states of matter, and it will be balanced, okay? So why would you want to use a word one? Well, the word ones are used to communicate to the general public that may or may not know what this formula means in chemistry. So, for example, they would know what lead nitrate is, or lead 2 nitrate, but they do not know that Pb may necessarily mean lead, or Ki means potassium iodide, okay? So when you do written text, you generally write the written word out for each chemical, right? And then there's many ways you can do it, and you can read those here. For skeleton equations, sometimes you just want to basically communicate to the reader that you just need these are the materials you have in chemical form. So lead nitrate again, or lead 2 nitrate again, and then potassium iodide. But you necessarily may or may not have them balanced or with the state of matter, right? There's a little error here. That shouldn't be a 2, right? And then the other thing too is for most people, they want the complete or best recipe, right? So the complete and balanced, and there's that would be that one. Okay, so there's a couple of things we have to be aware of when we write chemical equations, either from words or translating them back to words from formulas. All ionic materials are solids, unless in aqueous form, all right? So all diatomic elements, H2, N2, O2, etc., are gases. Aqueous means dissolved in water. Water is always liquid unless otherwise specified. And the following compounds have specific or unique names that don't match necessarily the naming sequence that we just learned. So H2O, which would be listed as dihydrogen monoxide, is called water. NH3, nitrogen trihydride, is ammonia or ammonia gas. And CH4, carbon tetrahydride, is methane gas. Right? So those are the kind of the guidelines that we're going to be using from now on. Okay, it's very critical that when you read a chemical equation, either through the words or through the formulas, things like these right here, that you understand which are the products and which are the reactants, right? So what you want to do is just look at these real quick, and you want to identify what are the products and what are the reactants, because that's going to help you understand if you have to write a chemical equation from the words specifically, or from the formula here into words, how are you going to, which are the products and which are the reactants? I'm going to give you a little hint, not necessarily in a word format, which are these right here, are the reactants always listed first. In some cases, if you want to highlight something, you list it at the beginning of the end, the sentence. So you could have, in some cases, products listed at the beginning of the sentence. And here's an example. Water forms when hydrogen gas is reacted with oxygen gas. So in this case, the water forms is the clue to give you that this is the product. In this one here, calcium carbonate decomposes into calcium oxide. So these are my products. Phosphorus reacts with oxygen. There's your reacts with, so that means reactants, okay? To produce, that's a clue for my products, right? Products and produce, right there it is. So not necessarily do the products always come last in a sentence. Sometimes they come first. However, in a chemical equation like these, the products are always listed to the right of the arrow. So again, here are the products and reactants. Okay, so if we're going from words, text words, to formulas, to write our chemical equation, reaction equation, there are a couple of guidelines or rules, right? You have to identify the products and reactants, determine if an ionic or covalent for each reactant and product. That's going to be important when you start to make the formulas. Write the correct formula for each. Remember, the ionic, we use the crisscross rule and the oxidation numbers, and for covalent, we use the Greek prefixes. So you've got to get the correct formula for that. Assign the correct states of matter, S, solid, L, liquid, gas, or aqueous, and then balance them. All of the materials that we've been teaching you up to date are going to help you, get you ready for this. So you got to know how to write formulas. You've got to know how to balance equations. You got to know what the states of matter are, things like that. So all the material that we've done since day one is now going to be used to help you do this material. Again, we're going to do the same thing when we go from formulas to words, right? Have to identify the reactants and products, determine if they're ionic or covalent, write the correct name for each. Remember, if there is a transition metal, lead or tin, you must include the Roman numeral to indicate the oxidation state. And then if you know the states of matter, solid, liquid, gas, or thing, then you have to write that. Remember, all ionic materials are solids. There is a mixture for covalent materials that could be either solid, liquid, or gas, but all of the diatomic elements, except for iodine, are going to be gas at room temperature. So oxygen, hydrogen, chlorine, fluorine, bromine, they're all going to be basically gases at room temperature. And then you're going to have to figure out from the other way whether or not it's a liquid or solid. I would say that a good portion of them are gases or liquids. Many of them are solids too, but for this particular thing, if you have a question, I would say that most are going to be either gases or liquids. Okay, so now we're going to try to write a skeleton and complete chemical equation from the following word equation. All right, so the first thing we're going to do is we have to identify what are the products and reactants. So I'm going to signify that the products are going to be red and the reactants are going to be blue. All right, so aluminum chloride forms when solid aluminum is reacted with chlorine gas. So this is my product. Okay, and then these are my reactants, chlorine specifically and aluminum, right? Okay, so now I have to figure out if they're ionic or covalent, right? So aluminum chloride, let's look at that. That has a metal, non-metal. So that's going to be ionic, so I need the oxidation numbers, and for aluminum it's +3, and for chlorine it's -1. So when I do if this is my product, right, I'm going to write my product over here like we normally do, so that's going to be AlCl3, right? And then there's an arrow that goes to that. And now we have to write our other things. Aluminum is reacted, so aluminum is just Al. And then that's reacted with chlorine gas. Now chlorine is one of the diatomic elements, the 7, so that would be Cl2, right? So there you go. There's your skeleton equation right there. I'm just going to write in green that this is my skeleton. All right. Now we want the complete one. So we'll have the complete one. Would we balance it? So we're just going to put down here again. And then we're going to put the states of matter. So this is going to be a solid, this is a gas, and this is a solid. Sorry. All right, and now we got to balance it. So let's balance it, and we're going to use blue numbers. So I can balance it real quick, and since I have a 2 and a 3 here, I know that the common factor is 6. So I'm going to put a 2 here and a 3 here. That gives me 6 chlorines. And then I can just put a 2 in the front here. And everything's balanced. So this is my complete reaction. So 2 aluminums plus 3 chlorine gas gives me 2 aluminum chlorides. And then here's the complete answers with a little bit cleaner notes, right? Notice the skeleton, I didn't have any. It's not balanced and there's no states of matter. But in the complete one, I have states of matter and it's balanced, all right? Okay, so we just went how now it's easy to write a word and skeleton equation from a balanced equation. Now, we're just going to write the skeleton one on here, and then I'm going to flip over to the next slide to show you the words one. All right, so this was going to write the skeleton one. Skeleton one, remember, just has chemical formulas, no states of matter, and it's not balanced. So it's pretty easy to write it from a balanced one. You just drop the coefficients. So you just write Al plus O2 gives me Al2O3. That's an O, sorry. That's it. There's your skeleton equation. It's not balanced, and there's no states of matter. And that's all you need. You just need the basic information for the chemicals. Now we're going to go to the next page and show you how we write it out in words. Okay, so we wrote the skeleton one again on this side, but here are some examples of the word ones that you could have written. Solid aluminum reacts with oxygen to form aluminum oxide. Aluminum oxide forms when aluminum and oxygen gas are reacted. Reacting aluminum and oxygen gas under the right conditions yields aluminum oxide. There's all kinds of ways you can write this, right? You just have to make sure that you are writing it so that you are carefully listing which ones are the reactants and which ones are the products, right? The wrong way to write this would have been something like aluminum and oxygen form from the decomposition of aluminum oxide. That is not what this equation tells us. This equation tells us, because the arrow is pointing in this direction, that we're making this, right? These are not the products, okay? So you really can't screw it up too badly if you just follow the way it's written.